Hey guys, my name is Ethan, this is Carberra, and welcome to Suze, where I teach you how to analyze and visualize data in Python. Today we are actually completing our graphing quote-unquote mini segment of the series, and we're going to be doing point plots, bar plots, and count plots. These are all quite simple, so I'm kind of leading you off of the graphing stuff with a not a lot to think about video. But yeah, they are some quite nice plots that you can find uses out of, so I thought I'd show you anyway. Of course, if you find the video helpful at any point, then consider liking to let me know, and subscribing so you don't miss out on future videos in the series. But yeah, with that out of the way, let's get into it. So this is the last video in the main series, at least, where we're actually talking about graphs. We're still going to be graphing stuff in the next videos, although it's mainly going to be more math stuff. If there's any graphs that I've missed, or if there's anything you want to see in particular, so if you want to see like joint grids and stuff, then do let me know in the comments and I'll start doing those in requests. I didn't do joint grids in the main series because I was just trying to overview it, but I can do more advanced stuff in case studies and requests. But I just wanted the main overview of everything, and then if people want extra stuff, then I can give it to them, simply put. So with this one, it's the most complicated imports of the lot. Everything is pretty much the same, these first two cells, apart from we're now importing median from NumPy. Although this cell is exactly the same. The third cell, we're creating a new data frame, and we're creating a new column called net subscriber gain. I'm not inserting it anywhere because I can't be bothered. But it's just the subscribers gained versus subscribers lost for a particular day, which we're going to use for the count plot at the end. I think I can actually show that column off because it will be at the end now. No, I can't. Well, no, oh no, I'm looking at the wrong one. Yeah, there it is. So we have 6, 7, 4, 3, 6, etc. If you want, you can insert that, but I can't be asked. To be honest, there's no real point. So all these three graphs I'm going to be going over are actually quite simple. The density and the box plots are quite intense as videos. This one is a little more chilled. There's not as much to do, which is nice. So we'll do fig equals plt.figure, and I'm going to be showing you the point plot first. Point plot data equals df x equals month, because it's still easier, and then y equals views, and then we're going to do fig dot show. So what this does, if I make it a little bit bigger, is it takes all of the plots from, say, month number 7, if we just focus on one in particular, and it plots a big circle on the average, so the mean. And then up and down here, we have kind of the range of all the plots. So this is sort of like the error tolerance. I'm not sure it's exactly the range, but it's essentially the error tolerance. So this is the average, and then it's kind of showing you how much deviation there is. And between each plot, it draws a line. So it's sort of like an averaged mean line slash scatter plot in a strange way. But you can see the error tolerance is slightly bigger for this one, and it's quite small for these ones up here. So it's sort of like an average thing, because obviously there are multiple entries with month 7, multiple entries with month 8, and it just kind of averages them all together, and it sort of gives you a summarized version of what's going on here. And that's why we have month instead of day, because if we had day, there's only one entry per day, and so it would just appear as a standard line graph. I suppose in a way then it's sort of like a group line graph, in a strange way. But there are a few options that we can put on this. So we can actually change the estimator. So the estimator by default is the mean. However, if you pass the median, and this is why we need to import it, because it doesn't take a string of median, it actually takes the function. And as you can see, it looks a little bit different. Okay, so it is pretty much the range, because the error tolerance is quite high on this one. But it essentially sorts the data and just takes the one in the middle. And apparently in number 8, that was quite low, because either that was quite a few outliers on number 8. But it gives us some slightly more unbiased error tolerances. But it's more or less the same graph, roughly. I think the curve is slightly less smooth. Yeah, the curve is a little less smooth. But other than that, it's pretty much the same. You can also do CI equals SD. So this changes, I believe what this is doing is it's changing the confidence interval to use the standard deviation. And what it does is it just makes the error tolerances quite a bit bigger in this instance. I'm not 100% sure what's happening in the background here, but I believe it's just getting the standard deviation, and it's setting the bars. So the larger the bar, the more deviation there is in the data. So this one has a larger bar than this one, as you can see. So it's sort of doing the same thing in a way. And then if you want caps on your bars, you can have them at 0.2. Oops, 0.2. And it will stick little caps on it like that. So if that's something that you want there, then you can totally have that. I think you can make them bigger as well. Yeah, you can make them like really quite large. So if I have a little one, it'll probably, yeah. They start looking like TIE fighters actually, that's kind of funny. We're just going to leave it, we'll have the estimator there. So we're not wasting the import. But yeah, that is essentially what a point plot does. A bar plot in this, in Seaborn, is actually quite similar because it sort of combines a histogram and a point plot, which is why I did it first. So sns.barplot, data equals df, x equals month, y equals views, and we're going to set ci equals sd because this is another option you can do with this. Show, and we have the bars here, so we actually have just a standard histogram with the bar plot. Although I believe, actually, I'm pretty sure it's doing the same as the point plot. Just where these circles are in the point plot is where the bars lie, or the top of the bars are on a bar plot. And you have the same confidence intervals here. So these lines are doing exactly the same thing as these ones, or I suppose more these ones in this case. But yeah, there's not really much else to talk about with a bar plot because a bar plot and a point plot is kind of the same. I actually kind of prefer the bar as well. And the final graph that I want to talk about in the series is the count plot. So this is sort of slightly different from a bar plot in a way, and I'll get to that when we get to it. So we do sns.countplot, data equals df2, and we have x. So we only want one axis for this, net subscriber gain. And essentially what this graph does is it just goes through and it counts how many of each number there are in the data set. So for example, if the net subscriber gain is 5 on 3 days, then it will come up as 3. If you do fig.show, I keep getting that wrong. This is what comes out. And because Seaborn chooses the colors for us, we actually get this really pretty graph that's like a rainbow across. So on one day, we had a net of -1. However, we mainly had nets of 5 and 6. So there were 30 days in total that we had a net of 5, and another 30 where we had a net of 6. A net of 8 was also quite popular. We did have one day we had a net of 17 gained, which is kind of nuts, and you have these values over here. But generally, if you were to draw like a density graph, it would probably go something like this throughout it all. But it's essentially just goes through and counts the number of rows where the number is, say, 3, 4, 9, 17. It's also not a scalar axis. So you can see it goes from -1 all the way up to 14, and then it skips to 17 because there aren't any days where I've got 15 net, and there aren't any days where I've got 16, but there was a day that I've got 17. So it just skipped over. But yeah, that's all I want to talk about in this video, and that's all the graphs that I want to talk about in this series, or at least the main part. As I said near the start, you can request, if you want to see other graphs, that you can request them, and I'll get to those in special videos. But in the next 3 videos, we're going to be doing some more mathematical stuff, so we're going to be tackling regression and clustering over those videos. So those are things you particularly want to see, and make sure to stick around. But I'll see you next time when we talk about linear regression.